This is Adora from the Capstone order tracking team. I'm going to be walking you through the front end of our website. So this is our landing page. And so once the user logs in, I want them to put in their username and password for CAS. So once the user is logged in, it's going to route them to the proper page based on their user type. So currently right now, my user type is a student. So as a student, I'm going to be shown my team's dashboard. So it states team number 9, the team name, Capstone order tracking, and then this is the dashboard. So just want to bring attention to some things like the navigation bar. So on the navigation bar, it displays the username of the person who is logged into the account. Home, if I click on home, it's going to redirect me back to this dashboard. And then a footer. So here, starting with the budget remaining section. So once the user submits the form, and then the form is routed to the TA or professor for approval, they approve it, and this budget gets updated. Now, as a user, I can request a budget increase. This is just the form for the budget increase request, the current budget. The user will input their requested budget, and then state a description as to why they need a budget increase. So now going back to the dashboard. Another thing I wanted to bring attention to is tooltips. So throughout the website, several buttons have tooltips. So here, it's just helper functions to help guide the user throughout the process. So here it just says request the professor to increase your budget. For the add part to order, add another item to this order and submit entire order for approval. So now here, we have basically the part order form, which states the order ID, add items to order, then submit form for approval. So the user will go ahead and fill out all these fields here within the form, the part name, vendor part number, manufacturer part number, description, link, part cost, quantity, etc. And so as they're adding more parts to the order, this order total is going to be updated. So the track of how much money that they're spending or anticipating to spend. Once they're done with that, they will go ahead and submit the entire order for approval. So moving on to the order history section. So the order history section basically states the date, time that the order was submitted, the order ID, and the status, whether it's been approved, denied, or not approved. So as we can see, the most recent order that we submitted has not been approved yet. And here are the details. So on this order details page, we can see some data like the part name, vendor, manufacturer, description, link, part cost, quantity, and total cost. And it states a message here that says contact your TA to be approved, and then back to dashboard. Now let's take a look at an example where the order was actually approved. So this order was approved by me. So if we click on this, we can see that here that there's some information about the order. And then the user has the ability to export the entire order to an Excel. And that's what it does here. And then we can go back to the dashboard. And so this order status section right now is just a placeholder until we're able to sort out the logistics as far as the parts receiving office goes and what that notification system is going to look like for the user. Now switching my user type to a TA, you can see that their dashboard or their homepage looks different, obviously, from that of the student. So a Mauser orders menu is available here, which is not available to students. We can see a teams list, which has all the teams that TA has, some information like the team budget, funds remaining, and whether or not there are orders awaiting approval. So this table is going to sort, basically the first item here is going to be the one that contains orders awaiting approval. Now these have been pushed down the list because they do not have any orders waiting for approval. So we can click here and we can see, okay, so this is the order ID, the date time it was submitted, and then the TA can go ahead and approve or deny the order. If we also click here, we'll see order details. or you can also approve all orders. Now let's switch gears to the Mauser orders pages. So here, assuming that the user submitted a Mauser part, it would be shown here. And then the TA would be able to, inspect this order and basically move this order to the cart. So this table will contain a list of all approved Mauser orders that have not been added to the cart yet. So just orders that have been requested on the student side. Now this view cart list page contains a table that has a list of all Mauser orders that have not been added to the cart. So it has some information like the part name, manufacturer costs, part quantity. And then the TA can click on this button, check out all parts in the cart. So what this will do is it will actually check out all parts in the cart using the Mauser API. Right now, this button will not work only because we do not have a payment system on file. But assuming that we did have a payment system on file, this would actually check out all the parts in the cart. Now going to this part summary, this shows a summary of all the parts that have been checked out, that have been ordered. So assuming I was able to click on that button in the previous page, these two items would appear here as a part that has actually been ordered. Now let's switch gears to the professor side of things. So the only difference between a professor and a TA is their ability to increase budgets. So that's why we now have this option in the nav bar here, budget increase requests. So every time a user requests for a budget increase, it will be routed to the professor only and not the TAs. So here you can see some information like the team, current budget, requested budget, and description. And the professor can either approve or deny and state a reason for denial. Other than that, everything stays the same. These are all the teams that basically are in the system. Now switching over to my code. All right, so here is our code base. So first and foremost, every .html file here has a URL path associated with it. So some .html files are full pages displayed in the browser, whereas others are embedded into a page. So we're gonna see an example of that. But for example, let's just say this budget increase form here. So this budget increase form is actually embedded as a form within the user dashboard. So starting out with our base.html, so this base.html file is basically the base layer for all the pages. It contains the header. So let's take a look at that. It contains the header, as in the nav bar, the footer, and the styling for both, as well as dependencies, which are libraries our pages use. So let's starting out with the dependencies. So the dependencies are placed here. So this is an example. So these are JavaScript libraries used for formatting and UI implementation. This Bootstrap CSS. So this contains a CSS framework that has all the libraries that we use for formatting and styling of the pages. Now scrolling down here, so this is the code for the footer. And so this footer is placed on every single page, as well as the navigation bar. So this navigation bar is placed on every single page. So here is how we're able to hide certain views. So for example, if I am a student, I will not be able to see the Mauser dropdown or the budget increase that's placed in the navigation bar. And as a TA, I will not be able to see the budget increase, which only professors can see. So here we don't have any cases like that for the professor because the professor has permission to view everything within the navigation bar. Here's some styling that I use for my navigation bar. And then here is the body of the HTML. So the body, this is basically a content block. So the content block is going to display information from these other .html files. And then everything else in this file is going to be basically placed around that page. This is just the body, which is the content of the page itself. So switching gears to the budget increase form. So this is an example that I was talking about as far as .html pages that are used as, for example, embedded forms instead of pages that we can view in our browser. I'd like to draw attention to the CSRF token. So this is basically a login token authenticating data is coming from an approved source. Now this form.asp function has a form class calling the asp function. So the form is passed from the controller to the front-end template, and then the template can use the object just like you would regular Python. So this budget increase form is used in the home.html. So this home.html is the user dashboard. So it has the dashboard title, a budget remaining section, and the order form, the order history, and order status. So these are examples of embedded blocks. So this is basically how we're passing information from the back end to the front end. So this team.number will state the number of the team. This team.name will state the name of the team, and then just dashboard. So this is the budget remaining section that we have here. This is our button to request a budget increase. And this is some styling also for this section. This is some JavaScript, which is used for formatting the tooltips that you saw earlier. So this is our order form. So this is an example. This /part form set.html is example of an embedded HTML file that is not used as basically a page that is going to be displayed in our browser. It's just an HTML file that contains information for the order form itself, which is then embedded into the user dashboard. Some styling for that. Then the order history. Once again, an example is the /order history table.html. This just displays the order history. And then the order status. This, as I stated earlier, is just a placeholder until we're able to sort out the logistics. Okay, so moving on to the part form set. So these are just some ways that we're able to handle errors within the form. So for example, if a required field is not filled out, it's going to throw an error. Or if there has been an input into a field that is incorrect, for example, if a user wants to enter characters in place of, if they want to enter the how much the part actually costs, they can only put numbers, for example. So it's going to throw an error if anything but a number is placed in there. Then moving on to our open order list. So this open order list is just a list of all the orders that the TA or professor needs to approve or deny. So for orders in open order list, it's going to state the order ID, the date that it was created, and then these are buttons to approve or deny the order. And then here is the reason where the TA or the professor will state the reason for denial. And then the button here that says approve all orders if the TA or professor wants to approve all orders. In the case that there are no orders for approval, it will state there are no open orders for this team. Now this teams list is basically the home page for TAs and professors. It's going to show all the teams that they have, the team name, budget, funds remaining, and the open order status. Then here, this is where information is passed from the back end. So the user is a TA, it's going to show the team name. Also, if the user is a professor, it's going to show the team name. they will be able to click on the team name and they'll be able to see the orders awaiting approval. And then here are other fields within the table. So this is going to be the team budget, the funds remaining. And this is basically how we are showing also on that homepage whether orders are waiting approval or if there are no orders waiting approval. So that is all I have to share.
Howdy. I'm going to take it from here. My name is Nicholas Casciola, and I was responsible for the Django subsystem backend as well as the database schema. So some of the things that I'm going to do differently in my side of the demo is I'm actually going to show you the functionality of the website, as well as how the Django subsystem interacts with the front end and how everything kind of comes together. So the first thing I'm going to direct your attention to is currently how we're running our application. So the application is currently ran with a simple command, python manage.py run server 8443. So this tells Python to run the server in this folder, which is our order tracker app. 8443 is the port that we are running the server on, and that is required for the cast dev access. If we're not running on this port, then we will actually be denied access to cast dev. So as you can see here, the system identified no issues. It gives you the date, our Django version, and then it tells you exactly where, which is our localhost port 8443. So right now, get over to the actual application and then see how things come together. So Adora went through the links and redirection on the front end. I'm actually going to take you through how things actually work. So we're going to go home. So currently, you can see that I have 3 teams in the test right now. Some of them have added orders and been approved, and some of them have not. We can see that right now, none of our teams have orders awaiting approval. So we're going to change that. So kind of as a back end, and this is probably going to be temporary, but professors have access to the individual team dashboards and can actually navigate to them manually through the URL given a team ID if necessary. This is really done for testing purposes, and so you still have to be authenticated by the system to be able to access this page. But if a TA or a professor would like to actually access the team's dashboard themselves, they're able to for right now. But once again, this is subject to change. You can see what, like Adora showed, I have the order history, the budget remaining, and the order form. So I'm actually going to go ahead and submit a part. So I'm going to submit a test part. We're going to say it's from Amazon. The vendor part number, I can enter in something random like 1, 2, 3, 4, 5. This also takes strings, so Amazon doesn't actually have vendor part numbers, so I can put not applicable. For the manufacturer, I'll say that this is a part from 3M, and then once again, Amazon doesn't give us a manufacturer's part number, so this is not applicable. I can write a description and enter in a quick link. This requires you to enter in a link. If you don't, it'll throw up a little error like Adora was talking about earlier. I can enter in a part cost. Let's say that this part costs $15 and I'd like 3 of them. I can click this add part to order button and the part will be added to the order. As you can see here, the part is shown and I can scroll and be given another blank form to add another part. So we're going to do test part 2. I'll say that this part is from DigiKey. I'll enter in another vendor number and a manufacturer. We'll say that this one is Raspberry Pi and this is the manufacturer's part number. I need this for my computing. I'll once again enter in a link. This is just a placeholder link. They'd actually enter in the link associated with the vendor website. The part cost, I'll say it costs $50 and I want 1 of them. And I'll add the part to order. As you can see, the order total is updated here in the bottom. And now that this order 13, which is the ID in the database, has parts associated with it, it appears in the order history table. Finally, I can submit the order for approval. The user is prompted that their order has been submitted for approval, and they're given a blank order to start fresh from, if they so choose. I can navigate over here and see that, and once again, see the order details. As you can see, now there are orders awaiting approval, and this team is put to the top. So that way, they're easier to see for professors or TAs. We're going to click here. So now I can go in and approve the order if I so choose with this green button. I can deny the order and give one of the necessary reasons, or I can approve all orders. Once again, the professor can inspect and go back to his open part list. So after inspection, they really need this part. I think everything's okay. I'm going to go ahead and approve. Now there are no open orders for this team. So if I were to navigate back to the team dashboard and pretend that I'm a student for a second, you can see that this order was approved by me, and you can give a timestamp, April 26th at 10:34 p.m. So let's say that the team decides that they need more money, or they have a corporate sponsor that is increasing their budget and they want the professors to know this. So they're going to request a budget increase. So the current budget is entered here and the requested budget is entered here. I'm going to request a budget of $1,800. We need this increase because we are bad at money. And I can submit the request. And then the user is prompted that the budget increase has been placed, request has been placed, and they're redirected back to their dashboard. I can navigate over to the budget increase request and see that now I have an open budget increase request. They're given the current budget, the requested budget, and the description as to why we need this. Well, they're bad at money. Well, that's not a good enough reason, so I'm going to go ahead and deny this. That request is now closed and there are no open budget increase requests. Now, I'm going to talk about some of the Mauser order stuff. So as you can see here, there are no open part orders for Mauser. So we're going to go here and we're going to find a Mauser part that we're going to enter into our part form on the front end and pretend that we're a student once again. And we're going to enter in this part into the form. The part's been added. I'm going to submit this order for approval. We're going to navigate back to the professor dashboard, pretending we're a professor again, and we're going to approve this. So now, if we go over to the Mauser orders, if we go to open orders, you can see here that a automotive connector from the Mauser vendor has been added. You can see the part manufacturer, the part cost, and the quantity. I'd like to add this part to the cart, so I'm going to add all parts. If I go view the cart list, you can see that I have a part that I have already added previously, another part that I've added previously, and then this new part that I've added. If we navigate back to Mauser and navigate to my cart, this is the account that I have using the API key. And then here's that part that I just added. As you can see here, this is the exact part that I added and it's in my cart. So if I wanted to, I could check out all these parts. Once again, I don't have a payment method on file. So this part is not connected, as it won't work. So if I click on it, nothing happens. This is mostly because I don't want to add a payment system to this account, but the code is already in place and all we have to do is link up the route similar to the other buttons seen in the team dashboard. So let's say that I am a devious student and I would like to access a route that I know exists that I do not have access to, like the professor's dashboard. It'll navigate me back to this dashboard. So even if I sit here and type in professors over and over and over again, it won't let me leave this page, which is good because that means that students have to stay on this page. This is pretty much the only page that students can really access, and anything that's kind of a child page of this, like the order details page. As you can see, my budget has been updated from previously, and I can go ahead and add another order if I so choose. So now I'm going to move over to my code. So here's my code base. So like I said, I worked on mostly the Django subsystem and specifically its backend components, different from Adora working on the front end components. And I worked on the database. So I'm going to walk you through kind of the routes of the Django subsystem, the models that we used for persistence data in the database. And then I'm going to walk you through some of the more important controller functions. That way you can get a sense of how they're working. So these are our base URL patterns. So you can see here the admin route will take you to the admin site. This is our users application, which handles login and log out. This is the tracker application, which most of our users will spend their time in. This is an index route, which figures out where users should be based off their user type. And then this is a Mauser order route for the Mauser order app. So in our users application, you can see our URL patterns here. So if I were to type in users / accounts / login, I would be directed to this route, which will redirect me to the CAS login page. Similarly, this logout route routes the user to log out of CAS. We do not provide our users a way to log out of CAS. The CAS principles state that it's kind of bad practice to allow users to log out through your application. And here's why. If we log our users out of our application, then they could possibly be logged out of their eCampus session, their Howdy session, or other applications that they did not want to log out of. So if they would like to log out of CAS, they can do so by navigating to the CAS website. However, this is a simple change that we could make if the professors desire us to add this. Here are the URLs for the Mauser order. As you can see, I have a path to view specific cart settings, like the currency. I can post a specific item to the cart using this action route. I can post all of the items of note to a cart. I can see the cart summary, the ordered parts, and all parts awaiting to be added to the cart. Here is our tracker URLs. As you can see, there's a lot more here because this is where most of the action in our application is taking place. The tracker has an index route that will figure out which dashboard the specific user is supposed to go to. So if a TA is supposed to go to the TA dashboard, professor to the professor dashboard, and a student to their team dashboard. The team dashboard is seen here. So this is our team dashboard version 2 method, and it is called by routing to the team /team and given a team ID in the URL pattern. It uses this team ID in the team dashboard, and I'll show you how that works later. You can see some of our other routes, but some of the ones to note are the TA, which is the TA dashboard, the professors, which is the professor dashboard, and the ordered. Given a specific order ID, this will show the details of an order. You can also use action routes such as the approve order, deny order, and approve all orders to approve / deny / approve all of the orders. We also have some testing routes for our about page that we're working on, and then our base HTML that Adora talked about earlier. These paths at the bottom are also action routes that allow users to export parts to CSVs. So a professor can export all parts. A student can export their team parts or export their order parts. The team parts is different from the order parts in that it exports all parts that are an approved order for a team. So all orders on a team associated with a team that are approved and their parts will be printed to this CSV file. So this is a good comprehensive summary for teams to see what parts they used and what parts they ordered throughout their Capstone design semesters. Let's change gears and take a look at the models.py for our tracker application. So obviously, you're familiar with the idea that we are adding parts to the database, and we want to keep track of what parts are ordered by what team. So here's how we do this. So the part object, the part class, is the child class for the order class, which is the parent for the part. As you can see here, that relationship is described here in this relational fields, under this relational fields comment. So the order attribute for a part is a foreign key relationship to the order table. So you associate a part with a specific order and its order ID. We have part information fields that store information about the part that we need to keep track, such as the name, vendor part number, manufacturer, etc. We also have an ordered field, which helps our Mauser order application keep track of which parts have already been ordered and which parts still need to be ordered through the Mauser service. We also have some helper functions here that help us set certain attributes or get certain attributes. These are just simple getters and setters. And then we have a special magic method for printing the part model. So if I navigate back to the admin side of things, there's a good example of how parts look using this method. So that magic method converts this part to display this information. So you can see here that we display the name, the vendor, and the vendor part number. This is just so if we decide to print the part in the log or in the admin portal, it's easy to read. We're going to move on to the order model. So as you can see here in the order model, it has two relational fields. So each order is associated to a team, and then each order has an order ID, which is its primary key. As you can see here, its primary key is true. They also have date fields, which are the date created, date approved, and date denied. They also have approval fields, approved and approver. And the approver field is a foreign key relationship to a specific user who approves the action. And the denial fields have similar, but also have an additional denied reason text field, which each part is associated with. So we can go and see why why an order was denied. We also have ordered for the order tracking stuff. And then we have a total cost of the order to keep track of the sum of the total costs of all of the parts associated with this order. Finally, in our tracker models, we have a budget increase request. Now this one's very similar to the order model seen up here. It's associated with a team ID. These are the fields that you saw in the form: current budget, requested budget, and description. And these are displayed to the professor once the student has submitted it. We also have approval and denial fields, just like the order. Date approved, approved, and approver, once again, a foreign key relationship to a specific user who accomplishes that action, as well as date denied, denied, denier, and the denied reason, and then another magic method for printing this on our admin/console. In the users, we have models that handle our users and teams. So you can see that there's a team model here. They have a name, a number, a budget, a funds remaining, and an open order Boolean, which displays whether the teams have an open order awaiting approval. We have a user manager class, which handles the creation of different user types. So as you can see here, we can create a user, we can create a super user, we can create a student, a TA, and a professor. Something of note is that this create super user function is required by the Django system to be able to create admin users to access the admin site. I just want you guys to know that this is different than creating a professor user. Here's our actual user model. So it actually extends the base user model that Django provides for us. And because of that, it has some fields that may seem a little strange. So the user manager manages the creation of the user object. That's what this is trying to say here. The email is an email field with a max length of 255, and it requires this field to be unique. Is staff, is active, is supervisor, and date joined are required by the Django subsystem. Not really sure why. I know that the is staff, is active, and is super user is used by the admin site to manage permissions there. And then we have our student, TA, and professor field. So if a user is a student, they will be marked as true. If they're TA, they'll be true. For professor, they'll be true. As you can see here, the default user type is a student. So that's something important to note. You can also enter a UIN for the student. This is kind of more on the admin side of things, so professors can more easily identify their students. They're associated with a team ID with a foreign key relationship, and their username field is considered the email. So we're going to move on and look at some of our controllers. So here is our tracker application, the tracker controller. So there's quite a few routes in this field. And so I'm just going to hit some of the more important ones and go over how we kind of handle different cases. Some of the actions are very similar. For example, posting form data is similar in the team dashboard as it is to the budget increase request, and in the denial reason field for denying parts. So I'm going to kind of not address those directly here, but you are more than welcome to request to see these during the Q&A session. I'll be happy to walk you through the code more specifically. Just for conciseness purposes, once again, I'm just going to go through some of the more basic functions. So this is our index route. So just as a refresher, if we go to our URLs py to tracker, this path is associated with this function in the views.py file. So we're in our views.py file now, and you can see that this index function is what it will perform the actions if that route is accessed by a user. So we're going to check and make sure that the user is authenticated. So if the requesting user is authenticated, we are going to allow them access to our website. Otherwise, we're going to redirect them back to the landing page to log in. If the user is a student, we're going to get their team ID and the team object, and we're going to redirect them to their specific team dashboard, passing their team ID so that the system knows which team to show data for. And then we're also going to print some log statements so that we can follow along as to what's happening in our application. If we're a TA, we're going to do something similar, except send them to the TA dashboard. And if we're a professor, we're just going to send them to the professor dashboard. We're going to take a look at the team dashboard, as this is one of the most important parts of our application, as students are going to be accessing this a lot. So once again, we're going to make sure our user's authenticated, and then we're going to start our logic. So we're going to grab the team and all of the orders associated with that team. This is just a base query layer that we will actually build upon later to get specific order subsections and filter the orders a little more. We're going to build our part form set. So our part form set is built from the part class we've shown before and uses the part form. Seen here in our forms.py, the part form is a class object that handles a HTML form that is used to submit data to the part model. You can see here that we have widgets attached to each field, so we can change how each field appears on the front end. So for example, I have a constant here that's a list of all of the approved vendors. And then the select options that you saw on the front end is formatted here in this widget. We can also put placeholders, seen here in the part name and part description. We can also indicate that this is a text area rather than a text field. So we're going to build that part form for this controller to use. If the request method is a post method, meaning the user is trying to post data to the backend, we're going to see what kind of data they're trying to post. So if they decide to add a part using the add part button, then we're going to get the last order, which is the one that the users are viewing right now. We're going to do a check for existing parts. We're going to set our form set values to get the parts associated with that order. If there are none, we're going to have the query set be none. And then we're going to check and make sure that the form set data is valid. If it's not valid, we're going to print an error message and redirect them back to their dashboard, basically refreshing the page. So for each instance in the form, this is a part. So for each part in the form, we're going to associate that part with the that part's order with each order. We're going to calculate the total cost, and we're going to save that part to the database. Once completed, we save the order by calculating its total cost and refresh the page. If they decide to submit an order, we're going to make sure that the order has parts associated with it, and we're going to update the order object with pertinent information and then save it. This is code that handles if a team is accessing their dashboard for the first time. And then we're going to pre-fill the form if a part has been added. So if one student goes and adds a part and doesn't submit the order, but another student accesses the page later, they'll see that their teammate has added a part to that order, and it'll be auto-populated for them. This is where we get the order history, and we exclude all empty parts just for in case something slips through the gap. And this also helps prevent every time the team loads up the dashboard, they're given an order. If that order has not had any parts added to it, we don't want that to display in their order history. I give the order status. This will be implemented once we figure out the logistical issues, and then I get the budget remaining. Now here's where the magic happens. I'll build the template objects, such as template variables, and then pass them to the front end for Adora to use. So that's kind of how a view controller works. So I don't want to take up too much of our time. So we're just going to discuss some of the more important action routes remaining. So if I would like to approve an order, this is the route that does it. Once again, students are not allowed to access this route. So even if they try to hack their way in, they cannot. So we're going to get the order that they want to approve. We're going to calculate the cost. We're going to update the team budget. If the order stays within their budget, then it's allowed to be approved. If not, and the approving user is a TA, they're thrown an error message. However, if the user is a professor, they are allowed to approve a budget overage and are notified that they approved a budget overage. And then finally, we can export parts. So we have 3 export action routes. Only one of them is currently implemented on the front end, and that's the export order routes. So we're going to get the order that we want to export. We're going to get the team associated with that order, and we're going to double check and just make sure that the user that is accessing the data, especially if they're a student, if that's their team. So we don't want a student to be able to access another team's data for whatever reason. And then we're going to export the order parts to a CSV, which is seen down here. We build the response type as a CSV and then return the response. Finally, I'm going to go through my tests. So here are all of my test cases for the tracker application. So I'm going to walk you through how a simple test works, and then I'm going to run my tests for you. So this setup function is called before every test function. So this test team dashboard is a test function. It'll test the team dashboard and ensure that we're able to access that route if we're a student. So I will dummy up 3 user types that each of these routes can use, each of these test functions can use. So as you can see here, I'm going to build a request. I'm going to create a team to the test database, which is a temporary database the testing framework uses. I'm going to associate our student user with that team. I'm going to save that student user, and I'm going to say that the user in the request is the student user that I defined up here. And then I'm going to actually call my view controller, passing my request and the team ID that I want to access. And then I'm going to assert that everything comes up all right. A status code of 200 means that it was successful. So now let's run our tests. So as you can see here at the top, a test database is created and all of the migrations are applied to that database. And then the tests are ran. So you can actually see the log statements being printed out. So this one is the approve all orders for the professor. So you can see here, I created the dummy users that I was interested in. I logged that I was approving all orders for this team. This team has an open order of ID 2 in the database. I'll calculate the cost of order 2. It actually prints out twice for debug purposes. And then I say order 2 was approved at this time. The professor also would like to approve, because it's approving all of them, will approve order 1. And then it'll calculate the cost of order 1. Order 1 has a cost of $24. And then it'll say it'll approved and the timestamp. So if I scroll all the way to the bottom, you can see that all of my tests ran, 33 tests in 34 seconds, and they all passed. So thank you guys so much. That's going to conclude my portion of the demo. I'd like to thank you guys so much, and I look forward to our Q&A session upcoming soon.